So here we need to find the area bounded by these two curves, and we're given these two curves f of x and g of x. And so there's always going to be a two-step process we use to approach questions like this. The first step is to find the intersection points, and then the second step is just going to be to integrate the difference between the two curves. And so we're going to follow those two steps here now. And the nice thing about these is that they're always the same regardless of what type of function we have. So we could have a trigonometric function, we could have a polynomial like this, or a log function, or whatever kind of function you come across, this is going to work. And so the first thing we need to do is find the intersections, and to do that we're going to set f of x is equal to g of x and see what happens. And so now we've just got this equation set up, and what we're going to do now is just turn it into kind of a traditional quadratic where we have something x squared minus something x minus a constant is equal to 0, and therefore we're going to find the roots. So we're just going to tidy this up here now. And so now we've got this expression, and we're just going to divide it by 2, which is going to give us x squared minus 3x is equal to 0. So now we factorized our quadratic the same way we always do, and so we know that our roots are going to be x is equal to 0 and x is equal to 3. Just setting each of our factors equal to 0. And so the next step here is going to be to use both of these x values to plug into our functions. You can choose either one to figure out where our y values are going to be for the intersection points. And so I've just chosen to plug them both into the function f of x. Again, you can plug them into either one because we know both of these points are going to be on f of x and g of x. And so x1 is 0 and y1 is going to be minus 3. And x2, y2 is going to be the point 3, 0. So those are going to be our two intersection points. And so what this means is that these 2 points are going to be used for our limits on our integration. And so if you can imagine, we know that one of these functions is a minus mountain function and the other is just a normal quadratic, so a u-shaped quadratic. And so they're basically going to intersect something like this, and the integration we're going to use between points 1 and 2, so we can say this is 1 and this is 2, is just going to give us this area, which is kind of the bounded area between these two quadratics. So now to find our area, we're just going to find the integral of f of x minus g of x, all with respect to x. And so by just doing that subtraction and being careful with our signs, we're going to end up with minus 2x squared plus 6 of x. And so we're just going to have to integrate this now. And our limits are going to be 3 and 0, because we're just integrating between our two x coordinates for our intersection points, which are up here in the top right, which are 3 and 0, and we generally put the higher one on the top of the integrals, so that's the reason the 3 is up in the top left, and this is going to be with respect to x. So now all this I have to do is just integrate this. And so just using our rule from our log tables for integrating polynomials, we're going to be just using this rule over here. So we just raise the power and then put the new higher power on the bottom of the fraction. So we raise minus 2x squared to be minus 2x cubed and put our 3 on the bottom of the fraction. And then we just do the same thing here, except it's going to be x squared and 2 on the bottom. And then we just close our brackets. And now our last step is just going to be to plug in the values of 3 and 0. So once we plug in our values, it's going to look like this. And just make sure to include also the minus sign and put everything in brackets on the right. But actually in this case, it's not going to matter too much because both of these terms are going to go to 0 because we've got 0 cubed and 0 squared. And so now we just need to simplify this kind of fraction. And that is going to give us minus 18 plus 27, and so that is going to be equal to 9. So it's going to be 9 square units. So that's our area. And the only other thing I'd say here is that if you end up with a minus sign, so let's say you have minus 9 square units, you basically just take the absolute value of that and just say that it's 9, because we don't really have a concept of minus area. But that's going to be your final answer, and that's going to be it for this question.